Okay, calculus, we're back. We got some more polynomials to deal with now. So section 2.2, we're going to get some things out of the polynomials as a review from what we've had in the past from Algebra 2 and from pre-calculus, things that we'll use again in calculus. So first thing to remember is that for polynomials, anything we have where we have something that equals usually we call this p of x equals a sub n x to the n, all these coefficients have to be real numbers, and all the exponents have to be natural numbers. So things that I can count, 1, 2, 3, 4. So no decimals for those, and no negative exponents for the n's. Okay, all of those powers have to be 1, 2, 3, 4, 5, and on up. Okay, all of these coefficients, these a sub n's, these things out in front of the x's, including that last one, have to be real numbers. That's what makes it a polynomial. And so we're going to identify some really nice things that when we know it's a polynomial, we'll take some shortcuts. First thing we're going to talk about is end behavior. And so the end behavior, in order to do that, you only need to identify two things. Okay? Step one, I need to identify what is a sub n. All right? If a sub n is positive or negative, we're going to look at these categories. And I also need to identify, hey, what about n? Now notice n is the largest exponent, so that's what we call the degree of the polynomial. And so we're going to take a look at that one. And we have two categories there, just even or odd. So if you remember, when we have an even function, it's either going to go touchdown, it's going to go up, okay, or down, okay? So if we have an even function, it's either going to do this U-shaped or the N-shape that we have right there. If we have an odd function, then they're going to do different things. Odd like a line, linear, okay, or cubic. It's going to, if it starts low, it's going to finish high. Odd is different, okay? That's another, odd is different. So either starts low and finishes high, or starts high and finishes low. So basically, this fits into four categories. If it's even, we know it's going to do this. If it's odd, we know it's going to have opposite actions. If the leading coefficient is positive, we know that as I go to the right, as x goes to infinity down here, that's what this is called, as x goes to infinity, that's going to the right, f of x will also go to the infinity. Because the leading coefficient always predicts what the function does off at positive infinity, off to the right. Okay? So I was thinking, as I go to the right, what's it going to do? Well, if it's positive, it's going to go up. Down here, the same thing. As x approaches infinity, f of x will approach infinity. That means it goes up. Okay? As x, if it's negative, if the leading coefficient is negative, as x approaches infinity, f of x approaches negative infinity. And likewise, down here, the same thing. The difference is, if we put those four things together, we can have four possibilities. It can start low and finish high, start low and finish low, start high and finish low, or start high and finish high. Those are our four possibilities, and this is the mathematical way to say it. Okay, so we want to get used to some of this, because that's what we'll do in calculus. So if I have g of x equals 3 minus 5x to the fourth plus 2x cubed, we're going to go ahead and say, all right, what does that do? All right? So I'd say as x approaches infinity, that's to the right, what will f of x be doing? Well, without even thinking about this, I have to find the leading coefficient. And so there is the problem. I need the leading coefficient, and that will be, remember, we only want to deal with the largest exponent. That leading coefficient is negative 5. So the leading coefficient is negative. As x approaches the positive infinity, f of x approaches negative infinity. That always happens. I don't have to think about it. But as x, excuse me, if the leading coefficient is negative, that happens, right? As x approaches negative infinity, what does f of x do? Well, now I need to get into this. Does it do the same thing because it's even, or does it do different things because the degree is odd? So I look at the degree up there, and I say, well, what is the degree? It's 4, which is even, so it will do the same thing. It goes to negative infinity. Hope that shows you, reminds you how you can figure those things out. And this is what we call end behavior. What does the polynomial do over here? What does it do over there? Off at infinity. Soon we'll have another name for that. Instead of calling it end behavior, we'll give you some new terms, and it'll be the same thing. So we want to make sure you understand that in the pre-calculus language. Okay? Here's another thing we're going to use a lot of. X equals a is a zero of a function, which also means x equals a is a solution of the function. Okay? That means x minus a is a factor of the function. It also means that a comma 0 is an x-intercept of the function. All of those four things are interchangeable. Okay? X equals a is a 0, x equals a as a solution means that f of a is 0. Those two things both mean that this will happen. The value of the function at a is 0. It also means that x minus a is a factor, and that a0 is the x-intercept. If I tell you that 2, 0 is an x-intercept, that means this, that means that, and that. It means we can say all those things. So it's all intertwined, it's all the same thing. So when I say that x equals 4 and x equals negative 2 are solutions to a function, that means that the value of g at 4 is 0. The value of g at negative 2 is 0. But you know what it also means? It means that 4, 0 and negative 2, 0 are x-intercepts. Okay? What else does it mean? Well, that means that x equals 4 is, did I say it was a solution up here? They said they're solutions. It means that x equals 4 is a 0. And it also means that if I were to write this, g of x, I know that I can write this, I might have something out in front, but I know that x minus 4 is a factor of it, and x plus 2 is also a factor. Now there might be some other leading coefficient that we have to deal with here, a, we'll call it, for the leading coefficient, but we know that this will happen because that was a 0. So that's important things to remember. And then one more thing, I hope you guys can still see it over here. I might just move you over a little bit, just to make sure. We go over here, when the degree of the function, remember degree is this largest exponent here. The degree is the possible number of zeros. Okay? So if the degree is 7, we could have 7 different zeros. Now we could have one 0 that happens 7 times. We'll get there too. Or we could have 7 different zeros. The degree minus 1 is the possible number of bumps. So what I mean by that is, if I have an x squared, you know, x squared is a quadratic, how many bumps are in there? 1. If I have an x cubed, how many bumps could I have? 2. Remember, these are only this over here only talked about the end, what's happening at the ends. This degree, there could be more bumps in the middle. So what we want to say is, if I give you a function, you know, and like here, and I say that we have q of x is, not 3, my brain is not working randomly here. Let's look at 4x to the 5th minus 2x, okay, plus, to the 4th, plus, plus 8. You know, and we want to say, hey, what do we know? I'm not going to tell you the rest of that stuff. What do we know about this that we can predict already? All right, well, we should be able to predict left and right behavior. We should be able to predict that as x goes to infinity, positive infinity, because this is positive, f of x will go to positive infinity. We should be able to predict that as x goes to negative infinity, f of x approaches, let's see, that's odd, so it does the opposite of infinity. I know it goes through 0, 8, so I have a y-intercept at 0, 8. I wasn't given any of my x-intercepts, so I don't know any of my zeros. No, we'll turn you guys back over here. I don't have my zeros, for sure, but what do I know? I know that because the degree is 5, I can have 4 bumps. Now, let's see, what does that mean by 4 bumps? That means that if I go down here to graph this, that means as x goes to positive infinity, I go to infinity. Okay, it's going to do this up here. Negative infinity, it goes on to negative infinity, so it's going to go down here. And then as I increase this, okay, there's 1 bump, 2 bumps, 3 bumps, 4 bumps. I can have at most 4 bumps. 1, 2, 3, 4. No, I don't have to have 4, but I have to be down here and get up to there. So it could go like this. And in that case, how many bumps did I have? 1, 2. I could have 2 bumps. Or it could just start here at negative infinity and then creep up there and then just go up. And there could actually be no bumps at all. Okay? But, so I'll call that the bump rule. It says that if you take the degree minus 1, that's the number of bumps, but it still has to have the same end behavior. All right. So that's a few things about polynomials. A couple more things that we're going to, you know, when you had this in, say, pre-calculus or advanced algebra, you know, you probably broke this up into more days, but now that it's just review, hopefully we can go a bit faster and we can still do it. How are we doing for time here? Okay, got about 4 minutes left. Here's what I need to know. I need to tell you about multiplicity. I need to tell you that if I have f of x equals 2 times x minus 1, the quantity cubed, times x squared, where are there zeros? Okay, well there's a 0 right here, and that happens when x equals 1 is a 0, so we have an intercept, an x-intercept of 1, 0, but x equals 1 is a 0 with multiplicity, we say, of 3. And now why is it 3? Why is the multiplicity 3? Because the degree of that factor of x minus 1 happens 3 times, so its multiplicity is 3. So if you look at it, this is a 0. We'd only have 2 zeros of this function, but the degree would be 5. Okay? X equals 0 is also a 0, but that has with a multiplicity of 2. Well, why is it 2? Because the degree was 2 for that factor. So the degree, this could be a degree 5, but there could only be, say, 2 distinct zeros, but this one happens 3 times, and that one could happen 2 times, and therefore we have a total of 5. All right? And so, you know, what we could do is, got the bump rule in there, we have the other ones, you know, and I have just an example here. We've got that example taken care of. You know, I think that pretty much covers it if we can get this multiplicity idea in here as well. Of the degree is that, oh, graphically, that's what I was missing. Okay, here we go. I've got about a minute. Let's do the graphically. What does this mean graphically if I just look at this thing right here? Well, the degree was 5. Leading coefficient was positive. So it's going to end up at positive. So this is going to go up here. It's going to, because the degree is 5, it's going to start down here. It's going to, as it goes negative infinity, it goes down. And because at 1 is a 0, I can go over here to 1 and put a 0. And at 0 is another 0. Okay? But what kind of 0 do we have here? Because that's an even degree, because this is an even multiplicity, what we're going to do is what I like to call a touch and go. We might have a bump in there, but we're going to have a touch and go there. And then, I'm just going to have it climb slowly up to there. And then we're going to have what we call a touch and go. It's going to look like a quadratic there at that 0. And then over here, because this one happens an odd amount of times, it's going to look like a line as it goes across there. And then it's going to go maybe go up there. And so, what we see is only 1, 2 bumps, but the behavior is predicted by what the multiplicity is. If the multiplicity is odd, it looks like a line when it crosses at that 0. If the multiplicity is even, then it looks like a quadratic. It does what we call a touch and go. It stays on the same side. So if it starts low, after it hits the 0, it's going to be low again. So that's a couple other things that we know about these polynomials. Okay? Sorry, I kind of crammed that in there. Hopefully that makes sense, and you can put that all together, remember, and use your previous knowledge to help you on your day 1 assignment. Thanks.